LeetCode is not really about memorizing hundreds of random problems. The fastest people in interviews usually recognize patterns. In this video, we will compress the most important coding interview ideas into one practical roadmap. Think of this as a greatest hits list. Hash maps, stacks, binary search, sliding windows, intervals, linked lists, heaps, trees, graphs, dynamic programming, backtracking, tries, and union find. If these patterns feel natural, many problems stop looking mysterious. The first must-know problem is to-sum. The trick is not nested loops. Store what you have seen in a hash map, and for every number ask one question. Have I already seen the complement? Valid parentheses is the classic stack problem. When you see an opening bracket, push it. When you see a closing bracket, the top of the stack must match. The stack remembers unfinished work. Binary search is not just a problem, it is an invariant. Keep a range where the answer could still exist. Test the middle, then safely delete half of the search space. That is why it is logarithmic. Sliding window is what you use when a brute force subarray or substring check repeats too much work. Move the right pointer to expand, move the left pointer to repair the condition, and update the answer along the way. Product of array, except self teaches prefix and suffix thinking. Instead of dividing, compute everything to the left of each index, everything to the right, and multiply those two pieces. Merge intervals is the interval pattern in its purest form. Sort by start time, then scan from left to right, merging whenever the next interval overlaps the current one. Linked list cycle is the two-pointer pattern. One pointer moves slowly, the other moves quickly. If there is a loop, the fast pointer eventually catches the slow pointer inside the cycle. Top K frequent elements is where counting meets heaps or buckets. Count frequencies first, then keep only the most important candidates instead of sorting everything blindly. Tree problems usually become simple when you ask, what answer do I need from the left child and the right child? Maximum depth is the smallest version of that recursive idea. Number of islands is the grid graph classic. Every cell is a node. When you find new land, start DFS or BFS and mark the whole connected component as visited. Course schedule is topological sorting. Courses are nodes, prerequisites are directed edges, and the question is really, does this graph contain a cycle? If yes, the schedule is impossible. Coin change is dynamic programming. Instead of trying every combination again and again, define DP amount as the best answer for that amount. Then build answers from smaller amounts. Backtracking appears when the problem asks for all combinations, subsets, permutations, or valid boards. You choose, recurse, then undo the choice. The undo step is what lets one path become many paths. Try problems are about shared prefixes. When many words start the same way, a try avoids rechecking the same characters repeatedly. This is why it shows up in autocomplete and word search style problems. Union find is for dynamic connectivity. You repeatedly connect nodes and ask whether two nodes belong to the same component. Path compression makes the structure almost constant time in practice. The real goal is not to memorize exact code. The goal is to look at a new problem and ask, is this a map, a stack, a window, a graph, a DP state, or a search tree? Pattern recognition is the cheat code. If you want the highest return on practice, master these patterns deeply. Redo the classics until you can explain the invariant, the data structure, the edge cases, and the time complexity without guessing.